Hey everybody, welcome back to my channel. It's Julian Blair. On this channel we do videos about computer science, the tech industry, and music. Today I am joined by a very special guest, my girlfriend, Laura.
Hello!
So today I thought it'd be fun if we forced Laura to do some coding interview problems typically seen in software engineering interviews.
Yay.
Now, I am a DevOps engineer with a background in CS, so I feel like I should be doing these anyway to stay relevant and, for the job market. But yeah, I'm not, so I'm gonna make my girlfriend do all of them for me.
Great.
Now, you don't do any coding at work now though, right?
Correct, I do not. I work as a litigation paralegal at a large law firm. Most typically, I'm working on large-scale bankruptcies, arbitrations, commercial litigations, and the like.
Gotcha. Okay.
No coding at work.
But you do have some coding experience, right?
I do. I studied linguistics and cognitive science, and as part of the program, I was required to take a handful of computer science courses. So I learned a little bit about Java, C, and C++.
So all the hard languages you got out before they taught you the easy stuff like Python. So for today's coding problem, we'll be using Algo Expert, created by YouTuber Clement Mihalescu. He's an ex-Google, ex-Facebook, awesome YouTuber and engineer, but it's basically a platform where you can practice all the coding interview problems, data structures, algorithms, all that kind of stuff. He did not give me a subscription. I have purchased it myself, but it's a great platform, so we're gonna use it. So today's problem is two-number sum. Would you like to read aloud the problem declaration?
Sure.
Great, so if you had to boil that down into like a sentence or two, what's the crux of the problem?
You have a bunch of numbers, and you're given a target number, and you want to find two numbers in your list that add up to the target number.
Great, exactly right. So in Java and C++, they're called arrays. In Python, they're called lists. So all the words in the problem are familiar.
Great.
So intuitively, how would we sort of think about this problem at like a high level?
So as a person, not a computer, trying to solve this, I would want to sort of go down the list and just check to see if any of the numbers add up together to the target number. And so as to not be doing the same thing over again, you'd sort of want to, in this case, check 3 and 5, and then 3 and -4, 3 and 8, 3, 11, and so on. And then, just keep moving on to the right. So check 5 and -4, 5 and 8, 5 and 11, and so on.
Why not check 5 against 3 again?
Well, because 3 plus 5 equals 5 plus 3.
Ah.
So you don't need to do it twice.
Exactly, we only need to go one way.
That is duplicative work.
Yes, it is. So how would we sort of set that up? How would we set up the problem?
Well, as a disclaimer, I don't know Python, so
okay.
There's an added level of challenge here, everybody.
Yeah, so I'll walk you through it. So we know that we need to basically go over each element, right? We need to do that probably a couple times, but we definitely need to go just down the list once. Overarchingly, per your description of how to do the problem.
Yes, and I do remember from my classes that I should be able to use a for loop for this. I presume in Python it's a little bit different than it is in the other languages, but
yeah, just a little bit.
Effectively the same.
Yeah. So while in other languages you might do something like for some integer I equals 0, and then you set some target condition or some end condition. So as long as I is less than however many times you want it to run, and then you increment I, right? So for I equals 0, I less than 5, I plus plus, and then you have your stuff in the loop. In Python, you can use a range function. So you would say something like for I in, and then range. And so the range function takes 2 arguments, or it can take 3, but we're gonna use 2 arguments rather. It takes the start index or start number, so 0 in this case.
Right.
And then the second is going to be how many times we want to iterate. And so based on our problem, how many times do we want to basically do the stuff inside the loop? How many times are we going to be doing those comparisons overarchingly?
Overall, it would be the same number of elements as are in the array.
Exactly. Right. So let's set that to be a variable, but above the for loop.
Okay. So that would be the length of the array, right?
Yeah.
And we could set that to be when array.
Nice.
Right? That's
yeah,
it? Okay.
Exactly. Yep. We did a little bit of a Python refresher earlier today,
Yes.
but you're still fuzzy.
Yeah.
Still fuzzy. All right. So, and then instead of an opening curly bracket like in Java or C, you'll just use a colon. And then everything indented underneath of that for loop declaration
Gets counted as
exactly part of the
Okay.
loop. Exactly. Perfect. So in this instance, this for loop just does what? It sets I equal to 0 at first, and then it goes up till the length of the array, right?
Yes.
So now let's say that I is 0 on the first iteration, right?
Yes.
So array at 0, because lists are 0 indexed, would be what element?
In the case of our sample, it would be 3.
Exactly. Right. So now we want to check 3 against what?
5.
And eventually.
And eventually -4, 8, 11, 1,
Exactly.
-1, 6.
Exactly. So what might we need?
We need to also be cycling through those numbers. So we're going to do nested for loops.
Yeah. It's coming back.
J in, this is going to be another range. And we want it to be 1 over from where I is to start there, right?
Yep.
Okay, so that would just be I plus 1. And you can put like +1 in the thing, right? Okay. And then we also want it to be stopping at the length, right?
Yeah.
Okay.
Exactly.
Colon, not curly brace.
Yes.
Okay, so once we're in that loop, we need to do math to things.
Yes. Yes, we do.
So we want to be checking if keyword there, if.
Yeah. Conditional statements. If statements.
It would be if I
So
plus something.
you're close. So what do these numbers that we have, the I's and J's, what do those represent?
Oh, those are the pointers, right?
Pointers, or more generally,
Right.
they're the place where we
Place
are.
where we are in the array. So it would be like if the array at I is, if the array at I plus the array at J equals the target, right? Is it also a colon here?
Yes.
Okay. Then we want to be returning a print statement, right?
So let's look at the problem definition again.
Because we want to be printing out what the two numbers are.
So the program will handle the printing.
Okay.
Our function should just return the numbers themselves in an
gotcha.
array. Yeah.
Okay, so I'd want to return array at I and array at J.
Yes,
Right?
but in themselves an array. So you would just put, you would just make that an array literal by putting brackets around them. Yep.
Around it like this? Gotcha.
Perfect. So that should work for all the elements if we do indeed have a pair that will sum to the target sum,
Yes.
right? What if we don't?
If we don't, should this be 2 equal signs?
Yes. Good catch.
Okay, so if we fail,
Yeah.
we will have cycled through everything without catching this conditional. So we would want to then instead return, it's to return like a blank, right?
Turn an empty array.
Okay, so we'd want to return, would it just be like a space?
No, just nothing inside.
Oh, just that? Just empty brackets.
Yeah.
Well, okay then.
Let's see what happens.
Should I run the code?
Yeah, run the code.
Run the code. Run the code. Wow!
Hey, good job.
Yay!
Great.
I passed all the test cases.
You did. I'm gonna tell you what's wrong with this approach. You did great. You did very well, dear. So nothing is wrong here. This is all correct.
But you just said it's wrong.
It's only a little bit wrong.
Julian.
It's not wrong. It's just slightly inefficient.
So it's not wrong. It's inefficient.
Yes.
What you spoke was a falsehood, sir.
Okay. Well, why might this be inefficient?
Because we're checking all of the things, and perhaps there's a way to check less of the things.
Sort of. Yeah, that's one way to say it. Basically, if we look at how many times we're doing this math here, this math and this equality comparison, right? How many times are we doing this line of code?
A lot.
A lot, because we have an outer loop that does how many things? Or that iterates how many times?
The length.
Exactly. So let's call that...
Maximum the length.
Right. So let's call the length of n things n.
Okay.
Right? So we do the outer loop n times. If we fail, in the worst case, right? And then we do the inner loop how many times?
Less than n.
Right. Less than, but also kind of close to
More or
n, right?
less.
On the order of n times, right?
Close to it.
Yeah. So we do the inner loop on the order of n times. N times for the outer loop. N times n is n squared. So we call that a quadratic time complexity, or O of n squared, big O of n squared. Oh, there's ways to do this that are a little faster. So if you click on solution 2 up here, we can try again in a different way. So
I have to do the same math twice, and the second time it has to be better.
it's different math.
Different math, great.
So what if I start this one for you and set it up a little bit?
I'm fine with that.
right.
Have fun.
So let's say there's a way to do this in only one pass of the array.
Okay.
So our target is O of n, just one
Okay.
time, right? So what if there was a way to already think about the numbers we need to get the target sum? So if we see a number, is there a way to find out what the other number we need is to get to that target sum?
Math. We can do math.
What math would that be?
Addition or subtraction?
Which one?
I mean, you could go either way.
So so I have the target sum and I have a number that I see in the array. What do I need to do to find out the other one that I need?
Target minus
Exactly.
what you have.
You can just subtract, right?
But you still have to check if the other thing is there.
Exactly. So what if there was a way to keep track of all the stuff that we had already seen?
That would be nice.
It would be nice, and it's called a set.
Wouldn't it be nice?
Right, so let's set this up. Let's say, set this up. So let's say for I in range.
Is that a joke that I didn't get?
We're dealing with sets. And I said, let me set it up.
And it's rage? Rage!
I'm gonna do the same thing you did.
Length.
We're gonna say for I in rain, blah, 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 blah. That.
Cute.
Okay, so
So,
the way that a set works kind of looks like an array,
okay.
but you can just check to see if stuff is in it really easily. So I'll set this one up.
Okay.
So the way that you define a set in Python looks like this. So let's just call it nums. And then you use curly braces instead of the square brackets.
Okay.
I missed 2. Right? And the way that you can check to see if something is in the set really quickly is just say, use the in keyword, right? So in
Okay.
this example, I'll say if 1 in nums, print true. And that will return. And the cool thing about this lookup, this in nums, is that with a set, you can look stuff up in what's called constant time. So if we did the same thing in an array, it would look at every element in the array until we got to what we're looking for. But here, it's just saying, is it there? Cool. And there's some magic behind the scenes of how that happens, but we can just look stuff up really quickly to see if it's there.
Wizardry!
Yeah, it's magic. For the sake of this problem, let's just give ourselves an empty set called nums. Right?
We would have to load in the things from array into the nums.
Exactly.
I don't know how to do that.
But we don't need to do it at the beginning. We can do it while we do our normal checking too.
Oh. Further wizardry.
Yeah. So what we can do preemptively is just say nums.add array at I.
Okay.
And that's just adding stuff to our set. Now this is going to get moved around, but this is something that we can do.
Okay.
What might we want to be checking for? So say we come to some random element in the list based on this for loop, right?
Okay.
What do we want to check for inside of this set? We want to check to see if something exists inside the set. What would that
We need to do the quick maths of the target minus the number it is that you currently have and are working with.
Perfect. So what do we want to call that?
J, I don't know.
We call it complement.
Complement?
Right? Because it's the complement of...
Oh, yeah, true.
So let's just call it complement equals, so what was it?
The target sum minus, I guess it would be I. Or no, it would be array at I.
Perfect. Perfect. Actually, we don't even need to do for I in range. We can just do, so I taught you this earlier. We don't have to use the I notation. We can just say for element in array. Because we only have one loop this time.
Okay.
So we don't need I and J to keep track of stuff.
Cool.
So in this case, we can just say, you remember this.
No.
So in Python, you have basically a for thing for each thing in this collection. In this instance, we have for element in array.
Okay.
So element will just be set to 3 first, and then the next pass will be set to 5. Next pass will be set to -4.
And so on
and so forth.
Up until 6.
Exactly. So now we have for element in array, we want to set complement equal to target sum minus element. So what do we want to check for inside of that set of numbers? We want to check for what?
We want to check inside the set if the complement is there.
Exactly. Perfect.
What about the edge case for the first thing? Because nums is empty right now.
That is true. Well, if we're on the first thing,
Yeah.
we have nothing to check against, right?
Yeah.
But what happens when if a complement does exist, that means that we'll check in the set at a later date, right?
Oh yeah, so we'll still have to add it, but we don't want to be doing other stuff to it.
Exactly. Very good. So we want to say, so what would that look like? If, remember I gave you that in notation really quick, if blank in the collection. So what would I say here for checking to see if it's in a set? It'd be if
complement in the set, so in nums.
Perfect. And then we want to say what? We want to return.
We want to return the 2 numbers. That works.
Great. And then at the end, we do want to add nums.
Yes.
We want to add 2 nums rather, the element. Right? I think this is right.
Okay.
Let's find out.
You wrote it.
Oh no.
Oh no, it's very not right.
We're back. So, quick syntax thing, you can't declare an empty set with empty curly braces. It's just the set constructor. Doesn't really matter, but now we're passing most of our test cases.
Great.
Which is fantastic.
All right, what are our issues?
Let's look. Our code's output. Oh, what did we forget to do? So
Print things.
So their code gave back an empty array. We gave back a null object. So we return this array because we found stuff, but we forgot to do what?
I don't know.
Return an empty array.
Return an empty array?
If we fail, if we don't find 2 things.
Oh, yeah, there should be something after the for loop.
Yeah, we just forgot to do that part.
Okay.
Or rather, I forgot to do that part. Oops.
Let's try again.
Hey!
Hooray!
Cool.
I'd just like to say that I passed
All
on the
the
first
tests,
try. Julian passed on the 3rd try.
So why is this a little better, maybe? We only have one what?
There's only one for loop.
Yes, there's only one for loop and we're only going through the list of things one
Once.
time. And we're also making use of cool set notation to just quickly look up to see if something is there. Good job.
Hooray!
All right, last one.
Wait, we're doing a 3rd one?
In this last one, we're gonna do
Wizardry.
a little bit more wizardry. Yeah, there's no guarantee that the array that we're given is in any particular order,
Okay.
right? They could all be all jumbled up. What if they were sorted? Would that help us in any way?
And could we rule out some numbers? No, we still have to check everything.
We still have to check everything, but we don't necessarily have to just go in one direction.
We can go in all the directions.
Well, precisely, we can go in both directions because it's a one-dimensional object.
Great.
Which has two directions. So I'll give you a hint. What if we started at the beginning and started at the end and we had two trackers?
Oh, then you could move in towards the middle.
We could.
But what if they're not necessarily going to...
Not at the same time. So check this out. So instead of a for loop, we're gonna have a while loop.
Okay.
We're gonna say while, so let's use left and right.
Okay.
So let's say while left is equal to 0, right? Is equal to
The length, right?
1 over a minus 1. This time we do need a minus 1 because it's the last index, which is 1 less than the length.
Right, yes.
So we'll say while, what would it mean if we got to the middle? What would left and right be set to if we got to the middle?
The same.
Right, they'd be the same thing. So we want to say, or they would cross over. They'd be the same or cross over, depending on if you have an even or odd number of things.
Yeah.
So we'll just say while left is less than right. Because if left is not less than right, that means that left has moved past right and is greater than or equal to. So let's say that. And what we want to do is what? We want to do some math to see if the left and right equal the target sum.
Right.
Right? So what would I write?
You'd want to...
Like, let's say we get a success. What should the success if be, if statement be?
It would be if the array at left plus the array at right equals the target, then we would be returning the two numbers.
Perfect. Very well done. Okay, that's one case. What's the other case? Obviously it's not equal, but it can be not equal in how many ways?
It can be greater than or less than.
Yes.
Yay.
Exactly. So let's move this logic up so we don't have to keep writing it.
Okay.
So let's just call this math, our sum. Oh, we can't use sum. Current sum.
Okay. And then you can take it out of the if.
Return, yep, that's all right. Okay, so now, so what was the first thing you said?
I don't remember.
Well, it could be different in two ways, not equal in two ways.
It could be greater than or less than the target.
Perfect. So let's say if current All right, what would that imply?
That it's greater than the target sum.
It's greater. So we would need to do what to that number to get to it?
We would need a smaller element in current sum.
Exactly. How would we get a smaller number for the next round?
We discard the bigger number?
Yes, exactly, in favor of a smaller number.
Yeah.
But how do we know that we're going to get a smaller number?
Wizardry.
Well, we told you that the array was what? Not random, but we did a sort on it, right?
Oh, right.
So
I
now
forgot
they're
about the sorting.
So let's actually put that in the code.
Yeah.
That would help, wouldn't it?
Yeah.
So let's say array equals array. Oh, sorted. Array.
Okay.
You can just do that magic in Python.
Great.
So this is going to add some time complexity, but not as bad as the first one that we did, where it was n squared.
Okay.
So it's not as great as the one we did before this, but it's still faster.
Okay.
So now that we know that we're sorted, we've got a left marker and a right marker. How do we get a smaller number if we know that the array is sorted?
So if current sum is greater than target sum, we would want to move right to the left.
Yes.
So we want to decrement right.
Exactly correct. Perfect. And then conversely,
If it's
cannot type.
less than,
We'd need a what number?
move left to the right.
Yes, we need a bigger number.
Yay!
We don't know if it worked yet.
Yeah, we don't know if it worked yet.
Well, let's
We
not
also
forget.
need to return if nothing happened.
Perfect. So basically we're gonna get some jig-jaggy movement
Okay.
until we get to the middle. So we might get, 3 left move overs in a row and then 1 or 2 right move overs until we find something that matches. Right?
Okay, let's try.
You can hit the button. It's the last one. Hey!
Ooh.
I'm proud of you.
Thank you. You did most of the work.
I know. Well, you did the first one by yourself.
I did do the first one by myself.
Yeah. Expect to see many more difficult problems in an actual software engineering interview.
Great.
So I'm extremely proud of Laura. She did a really great job. I'd like to thank Clement for making this app because it's fantastic and hopefully will get me many jobs in the future. I'd like to thank Laura for being here and joining me in quarantine. And I'd like to thank you for watching. So if you would like to
Like, subscribe, comment, and don't forget to wear a mask.
Hope you all are doing well. See you in the next video.
Bye!